Hi students, today topic we are going to see about pyrometer. What is the use of pyrometer? We should understand pyrometer, it's a device used to measure temperature. So there are so many devices used for measuring temperature: thermocouple, thermistor, RTD. Then one more device is called pyrometer. Why we are going pyrometer? Pyrometer is a technique for measuring temperature without physical contact. If you want to measure the temperature at the boiler section, or the person can't able to enter into any particular place, location, or you want to find out the temperature of a very hot body or electromagnetic radiation emitted by the body, then we are in need of measuring temperature. So those application, the people used to go for pyrometer. So this pyrometer, pyro, it's a Greek word which means fire. There are two different types of pyrometers we have. One is radiation, then another one is called optical pyrometer. So how they are differ, radiation pyrometer as well as optical pyrometer. Just look at the diagram here. There are so many devices they have denoted, and this is how I want to measure the temperature of this particular location, but the person can't able to reach, so they are using a meter. This is what actually the device called pyrometer, that is infrared. So using that device you can able to identify the temperature of this particular location. So it look like this, and here inside you can able to measure the temperature, then moisture, that humidity, that can also able to measure using this type of instrument. And this is what radiation pyrometer. So these are the devices the people they are having in industry point of view. So what is that pyrometer? So generally this pyrometer has an optical system and a detector, and it is mainly focusing on the principle of Boltzmann law. The system focus thermal radiation onto the detector. The output signal of the detector is related to thermal radiation of the target object. The constant proportionality they used to call Stephen Boltzmann. So here this equation J, which is equal to sigma into T power 4. So by the use of this expression, they can able to calculate the value of sigma as well as the temperature. Sigma is a constant value, that is what called as an Boltzmann constant. So this is what radiation pyrometer. So radiation, here just we are going to measure the temperature. For very high temperature we can use this radiation pyrometer. Application is furnace temperature. So this furnace temperature you can't able to have a physical contact. So the medium is very heat, I mean like the temperature range is above 700 or above 1000, so you can't able to measure. In that particular system we are using radiation pyrometer. It measures the radiant heat emitted or reflected by a hot object, or we can call it as an electromagnetic radiation emitted as a result of temperature. And moreover here the radiation is about 0.1 to 100 micrometer, and the value they are measuring using Q, which is equal to 5.72 into 10 power minus 8 into E of T1 power 4 minus T2 power 4. So that was the equation they are using based on Stephen Boltzmann. So under this expression, your E we used to call coefficient of emissivity, and T1 is called absolute temperature of the hot body, T2 is an surrounding temperature. And how the working? This particular meter, we have an optical system which is nothing but you have a lens and mirror. Then we have an adjustable eyepiece. So this is your adjustable eyepiece. The heat energy emitted from the hot body, this is what the hot object, that will entering into the lens, then it will focus through the mirror section, and here we have a detector. So whatever the rays coming out, that whole thing will be collected through the detector part, and with the help of this mirror and the eyepiece arrangement we can able to see the radiation coming out from the hot object. And here the detector, they can go for thermistor or photo multiplier tubes. So using that detector, the signal is output is electrical signal. So here this detector is act like an transducer. So the form maybe like the heat energy which is converted to corresponding electrical signal by the detector, we can get the output in terms of temperature. That is what radiation pyrometer. So in total radiation pyrometer, both visible and the non-visible light sources, whatever the radiation coming out from the hard body, the whole thing will be observed through the lens and the mirror as well as the detector system. Then what are the advantages? It can be able to measure high temperature, fast response, high output. And the disadvantages are emissivity error. That means if during the operation, if there is any emission, then there will be an error. Then there is an error due to absorption of radiation by carbon dioxide, water or other apparently transparent gases. Then application point of view, they are used for temperature above the practical operating range, and it is also used for moving target. They are using for measurement of average temperature of large surface areas. They are used for target which would be damaged by contact with primary elements like thermocouple and RTD. So here you can just look at here, the range is 1000 to 5000 degree Fahrenheit. For we can measure the temperature of furnace, molten and other heated material. So the another type is optical pyrometer. Optical pyrometer working on the basic principle of using human eye, here human eye, to matching the brightness of the hard object to the brightness of the calibrated lamp filament inside the instrument. The radiation from the source is emitted and the optical object lens capture. The lens helps in focusing thermal radiation onto reference bulb. So just look at here, you have an eyepiece, here you have a lamp. Based on the radiation, the people can able to identify the temperature range, whether it is high or low or cold. So here the reference position, we have a rheostat, battery and a multimeter. So adjusting this rheostat to finding the current across this particular lamp position. So through this eyepiece, here this is a temperature source. So how much amount of that temperature range, based on that the brightness of the lamp that will indicate it. So here we have an objective lens, we have an outer tube and inner tube. This is an absorption screen and we have a filter. So this is just for brightness of this particular light. So we can initially they will adjust using this rheostat and multimeter. They will setting some value through this reference temperature lamp. After once from the temperature source, according to the temperature range, the brightness of this lamp is going to getting varied. So you can just look at, this is what the brightness and this is the filament. You can just look at here, there are three things. The first one is the filament is dark and cooler than the temperature source. Then here the filament is bright, that is hotter than the temperature source. Then here no filament disappear, that means the brightness between the filament and the temperature source. So through eyepiece, the observer can able to watch the process through eyepiece and correct it in such manner that the reference lamp filament has a sharp focus and which is superimposed on the temperature source image. So from these observation, we can able to understand the temperature range of the pyrometer. So it is very simple, easy use and provide high accuracy. There is no need of any direct body contact between the optical pyrometer and the object. Can also use for wide variety of application, and it's a measurement based on light intensity. The device can be used only in application with a minimum temperature of 700 degrees Celsius. The device is not useful for obtaining continuous values of temperature at small intervals. It is also used for measuring highly heated material. It can use to measure furnace temperature because the temperature range is very high. This is how your radiation pyrometer and optical pyrometer is working. Using those two, we can able to identify the temperature of the hard body, and moreover, if it is not in contact nature, in those surface also we can able to measure the temperature using this pyrometer. Thank you.